So you got a question then?
Watch. Number 9.
On the back side, I think.
Yeah.
Or nope, it's at the front side. This one right here.
Yeah.
Okay, number 9. Let's do number 9, guys. That's an oldie. Okay. That's an old one. I can guarantee you're gonna have one like number 9 on the quiz. Okay, it's an old one. Okay, on number 9, where's angle CAF at? Right there. So angle CAF is 70 plus 35 together plus, well, whatever CAD is. So I need to go figure out what that CAD is and then add it together with the 70 and the 35. Well, I don't know what CAD is though. So I need to first figure that out. For me, and there might be more than one way to do this, but for me the first thing I noticed is I got everything up there besides CAD. So what I'm going to go do is take 360 degrees, take out 95, 130, 70, and 35, and that gets me CAD. So on my calculator, I'm taking 360 minus 95 minus 130 minus 70 minus 35, and what I just found was this to be 30, and now I have 70 plus 35 plus 30, and that gets me that 135. Okay? That's an oldie, but it's still going to keep coming out. Okay. All right. Somebody else has another one. Patrick?
Can we do 2 on the back?
2 on the back. Let's flip it around, guys. That's an oldie. Let's look at the next one. Find me the coordinates of the center. Well, the center is right there at the origin, which leads me to then the length of the diameter. The diameter from through the center, we can just quickly see from -3 to 3, that's length of 6. All right, and then if the diameter is 6, the radius is 3. And now we got the area. As soon as we know what the radius is, boom, we've got the radius. Sorry, we got the area. Just make sure you use the right formula when. Area is pi r squared. Radius is 3, so 9 pi. And we also got the circumference formula, 2 pi r. 2 pi r, radius is 3, 2 times 3 is 6 pi. Now after that, directions do ask you to round it. So go to your calculator and plug in 9 pi and 6 pi. 9 pi tells me what? 28.3. And then for the other one, 6 pi tells me what? 18.8. Okay. All right. Again, that's an oldie there. Nice one. I'm gonna pop that out. Keep popping that out to you. Good ones to go around with this topic of circles. All right. Other questions you got? This is your time to ask. Number 1. Okay. Another good one to keep talking about. Area. It's a shaded figure. Okay. On that area of shaded figure, we want to take out that circle. So we got a big old trapezoid to start off with. I'm curious for trapezoids. Trapezoid's made up of a rectangle and a triangle there. Find me that rectangle. All right. Area of that rectangle. 22 times 20. 22 times 20. 22 times 20 is what? 440. And we're going to add on to that rectangle a triangle. Now that triangle is 1/2 base right here times that height of 20. Now that 32 is everything. Subtract out that 22. So that's 10. 10 times 20 is 100. And together they add up to 540. So now what we just found with that 540 is the area of that big old large figure. Okay. We found the area of that big old large figure. That's how you find the area of any shaded region. The area of the large, subtract out the area of the small. Now the small figure happens to be a circle. So let's go find the area of the small figure. Okay, every single shaded figure, large minus the small, large minus the small. Okay, area of the circle. So subtract out the area of the small. Pi r squared. Radius is what? Coming from this 20. 10. Okay, yep, the diameter is 20, radius is 10. 10 squared is 100. All right, so 540 minus 100 pi. That is my shaded region. So that's my answer. That's my shaded region. 540 minus 100 pi. It looks weird. And that answer is fine. I would be happy with that answer. If the answer said leave it in terms of pi, I'd be done. But the answer does not say leave it in terms of pi. The answer says round to nearest tenth. So 540 minus 100 pi, I'd be done if it said leave it in terms of pi. But it doesn't. It says round to nearest tenth, so let's finish it off in our calculator. 540 minus 100 pi. Calculator says nearest tenth, 225. Point, what was it? 0.8. So this is like if you roll out cookies and you get cookie cutters and punch out the cookie shapes with your cookie cutter. That's the idea. Bless you. All right. Anything else anybody's got? Those are good, all good questions. All right. Make sure your name's on it. Throw in the basket. And let's get out your notes and get out that formula sheet and get out your calculators. Don't have your calculators out. Let's get ready to get going here. Formula today. All right, first off, the direction says find me the area. Number one doesn't get any easier than that. Find the area of that circle. Answer is what? Area of that circle is pi r squared, so 100 pi, right? Units are inches squared. Okay, gentlemen? Sure. All right, now, it's the exact same circle, but now we're finding the shaded region of those other two. And on letter B then, somebody, what's the answer for that one real quick? You got an answer of what?
50 pi.
50 pi, right? Now, how do we get to that 50 pi? Grant, how'd you do 50 pi there?
Well, I divided 100 by 2.
Right. And instead of dividing by 2, what's another way we can think of dividing by 2? Multiplying by 1/2. I know it sounds silly, but I do want us to think about it like that. And on the last one there, letter C, how do we find, what did you get for an answer of letter C there?
25.
And how did you find the answer for 25 pi then?
Multiplied it by 4.
Multiplied it by a fourth. Those answers aren't too crazy. And off of those, let's come back around to those. Now the way that I wrote this out on B and C should look very similar to the back of that note, that formula sheet from ArcLink, from the work that we just did from Friday. 1/2 times 100 pi, 1/4 times 100 pi. The same idea that we just did. Now, instead of 1/2, what does 1/2 represent in terms of a full circle? 1/2 is what of a full circle? 180 over 360, right? Times pi r squared. And what does 1/4 represent out of a full circle? 90 over 360. All right. So that, again, should look exactly familiar from Friday's work, except instead of 2 pi r, we're using pi r squared. Instead of arc length, what we are doing today is, what's today's lesson say? We're doing a sector. So we're pretty much done for the lesson now. Okay? What we're talking about is what you just found on B and C. We call those sectors. Okay? So that's it. That's the modified formula today for the area of a circle. We call this an area of a sector. It's a fraction of the area of a sector. That's what we're doing. It's a fraction of the circle times the area of the circle. What did we say on Friday? We said on Friday, we said it's a fraction of the circumference. Today, it's the same idea. Instead, though, it's a fraction of the area. Okay? Same formula, same idea of the formula, except either times it by the area or times it by the circumference. Make sure you do the right formula window. Read carefully. So, sectors. Let's talk a little about sectors here. So what is a sector? A sector is a region bounded by an arc. So we got this arc and then the 2 radii. So when you saw up there with the quarter that you just did on letter C, you've got the arc and then the 2 radii. Now we name a sector here by using the 2 arcs endpoints and then the center. So in this example right below us, the way that we would name out this arc, we can name it usually kind of a couple different ways. We can literally name it as just say arc sector ARC. We do write the word sector. There is no like symbol for sector. We usually write the word sector and then we write out in letters what sector you're referring to. Sector ARC. Okay. So there's your formula then off to the side. So we already did that up above. And what I would say for yourself now on the back of that formula sheet, just like I had you guys do on Friday, on the back of that formula sheet, right next to arc length, I would write area of a sector right there. It looks exactly the same, except we're using area instead of circumference. And on Friday's quiz, please read the directions carefully. Use the right formula when. The directions will be very specific. It does say find the length of the arc. It will say find the area of the sector. So use the right formula. It will say circumference. It will say area. Just use the right formula when. But I always have, I say about a quarter of the kids don't read carefully and use the wrong formula at the wrong time. Okay? So let's flip it. Let's do a few sector problems today. All right, get your calculators up, don't run that out. And let's take that first one there, people. Where they look like Pac-Mans on the back side. Let's do that top one there. Find me on that first one there. Find me the area of that sector, as you can see where it's 100 degree arc. Find me the area of that sector. Okay. 100 over 360 times, all right, area of the circle, pi r squared. I always do off the side real quick the area of a full circle, or the circumference of a full circle, depending on what formula I need to use when. But pi r squared. Now you all can do that in your head very easily. Radius is 6, so 6 squared is 36 pi. And then that's it. Go to your calculator. Probably can do that in your head too. Let's go to our calculator. Okay. 100 over 360 times what? 36. Don't type in pi, reminder. Your calculator cannot handle that pi in there. So what's just 100 over 360 times 36? Somebody get 10? Now 10 pi. Tack on pi when you write it right here in this answer blank. That is my exact answer. Includes pi. 10 pi, my units are meters squared. Now, as we've been doing throughout the school year, we like the exact, we like the approximate, nearest tenth, 31.4, I believe, right? 10 pi, type it into your calculator. Directions say, or the calculator says 31.4. That's it. That's as crazy as sectors usually get. It's nothing really too bad. Okay, go with another Pac-Man there. Much larger one. The area of that sector right there, almost a full circle, not quite. 315 over 360 times pi r squared. But I need to go off to the side and do a quick calculation with the radius of 13. So 13 squared. But you should be able to do 13 squared in your head. What is 13 squared? Now, go to your calculator and run that through. Might come out nice, might not. I don't believe it terminates nicely. 315, not yet. Almost there. Not even close yet, is it? 315 over 360 times 169. Hit enter. Okay, we talk about fractions and pi, right? We don't want decimals, so change that over to a fraction. So get good at that. Hit math. Option 1 right there, fraction. It's gonna look ugly. Who cares? 1183 over 8 pi. 1183 over 8 pi. Units are centimeters squared. Okay. Now round it to nearest tenth. Go back, plug it in, give me to nearest tenth. All right. Nearest tenth. What is 1183 over 8 pi? Somebody get 464.6? Always, again, you're sitting there plugging that in as well. Don't just sit there and stare at the board. You should be double checking that same work as well. Okay. That's, again, about as bad as it gets. Just make sure you're using the right formula. All right, let's go down. Let's do the next one there, number 3. Let's work it backwards, guys. What do we mean by working backwards? Well, number 3, we got the area this time. We got the area of a sector. Now, we've done some of these working backwards before. So, you got the sector as 36 pi, and you've got the degree as 300. But the thing that we don't know is the radius. That's what we're trying to find, isn't it? So what we need to do is use our equation skills. We're done with geometry. Let's go back to algebra and solve this out. Okay. Start solving for r. Well, first off, what's going to happen to those pi's? Pi's are on both sides. What's going to happen to those pi's? They're going to cancel out, aren't they? So we're going to divide both sides by pi. Those pi's cancel out. Okay. Boom, boom. Those pi's cancel out. Those pi's cancel out. No big deal there. Alright. Now we got, again, we're going back to equations. We're going back to 6th and 7th grade equations here. Trying to get r by itself. We got to get rid of that 300. We got to get rid of that 360. We got division. What's the inverse of division, people? Correct. So if we are dividing by 360, we need to multiply by 360. That's nothing new. Those 360s are going to cancel. Great. But let's also do this at the same time. We cancel out the 360s. Great. Now we have 300 times. What's the inverse of 300 times? Division. So we're going to also divide by 300. And what happens to those 300s? The inverse is 300, right? It's going to cancel out the multiplication. And what we end up with is r squared here, and this is going to go into my calculator. 360 over 300 times 36. Let your calculator do the work for yourself. Okay. Got calculators. There's no reason to think that through. Times it by 36, we said. Answer is, so we got 43.2. Now this is a quadratic. We know how to solve quadratics. Square root both sides, right? And then go to your calculator. It does not turn out to be a nice number. So directions doesn't tell us to round it. We can't reduce that nicely. So let's just go to nearest 10. Square root of 43.2. Somebody, nearest 10. It's 6 point something. 6.6. I think that was what we got first hour.
Yeah, I got 6.
Sounds good. 6.6. Okay. So that one's a little bit more involved because we're using our equation skills. Nothing crazy. The geometry is the easy part. Setting up the equation. All this relies back on your algebra skills. Okay. All right, let's go walk it over to number 4. Take a minute, read through number 4. Think of a game plan there. So read through number 4. You want to find the area of a circle that's just solely in which quadrant? Quadrant 2. Where's quadrant 2 located? Top right, bottom left, where at? Top left. Now when they say the area that's contained in quadrant 2, what are we actually talking about here? Talking about a what? Quarter, which represents what? Arc length, area of a circle, sector of a circle.
Sector.
It's a sector problem. Does it say sector? No, but what it is representing is a sector problem. So that's what we're doing right here. We're trying to find a sector problem. Right. So let's go ahead and do our sector formula. Now, somebody just said a quarter, which is exactly correct. 90, oops, not 900. 90 over 360 pi r squared, because you told me sector. Pi r squared then. What's the radius though? What's the radius of that circle? 5. Yep. From the center right there. Whoops, I didn't go to the center, did I? I don't know what to do. Okay, I did not go to the center nicely. Try this again. That's better. All right, yeah, the radius is 5. You can just count from the center. So 25 pi. Now, if you went to your calculator and typed it in, cool. Or quarter over 25 is 25 fourths, right? So we're done. 25 fourths. If you type in your calculator gives you a decimal. So we want fraction pies. 25 fourths. Pi. Units, we don't have them, so we say units squared. Okay? So, on some of these that we work on, you got to realize when you read through there, hey, that's just a sector problem. Last one, read through number 5. Same deal, read through number 5 there. Think about what it's asking you to do. Symphony of noses this time of year. All right, what do we got going on with that one, anybody? Should be arc length. It doesn't say anything about arc length, but as we start at 0, 5, or 0, 5 at, think about which way direction is counterclockwise. And we're going to go to 5, 0, so 5, 0 is right here. Depending which way counterclockwise is, makes the long trip or short trip. Counterclockwise is the long trip. And by them telling you walk around the circle, around the outer path of that, that is talking about arc length, okay, as the partial circumference. It's a fraction of the circumference then, because we don't go all the way around, we only go to that point right there at 5, 0. So what we again are doing here is plus, yeah. We are doing arc length. So from Friday now, back to Friday, what are we doing here again? A fraction of circumference. What was the degree measure then that we have here? 270. As we sketched that out then, we did quadrant 2, quadrant 3, quadrant 4, which is representing 90, 90. How many 90s was that? 90, 90, and 90, which is 270 degrees. Over always 360, but again times 2 pi r. Because again, it's arc length. And what's my radius? Is my radius still 5 on that circle? Yes, it is. 10 pi. Radius is still 5 here. Okay, finish it off. Go to that calculator of yours. 270 over 360 times what? Times 10. And what do we get there, guys? 7.5. Now, the directions say round it to nearest tenth, doesn't it? So I'm going to put 7.5 down, but I don't really care about it because the directions do say round it, so I don't need to change this to a fraction. Who cares? I'm just going to go right back to my calculator and say, what is it, calculator? To 7.5 pi. So calculator, what is it? It's not voice activated though. 23.6. And this is circumference. This is distance. So it's not squared, just units. Now, if you were to say, hey, I just walked 23.6, if I just walked 7.5 pi units, like who talks like that? It's weird. Okay? Those are the times where it does make sense to round that to whatever feet that is. 24 feet, that makes more sense. All right. That's where we'll pause things, guys.